Okay, good afternoon, everybody. Thank you very much, Mr. Chairman, for introducing me. And I hope all the participants are well and safe and healthy in this pandemic. And thank you very much for TAMA, Turkish Additive Manufacturing Association. I'm very honored to be part of this association as a member, as a founder, president. And so as Mr. Chairman said, normally these days, we ought to organize the AMC Turkey 2020, but during the pandemic, so therefore we actually passed this year, so we organized these seminars. And today I would like to give you a talk about what we are doing in my research group, of course in additive manufacturing perspective. So, well actually, I have a research group which is located in Gazi University. We call it as Advanced Manufacturing Technology Research Group. And the Gazi University Engineering Faculty is located in Ankara, capital city of Turkey. And this is our actually the faculty building, and my lab and my research group is located in this building. And first of all, I would like to give a very brief introduction to my university, which is Gazi University, and founded back in 1926, but named in 1982 as a Gazi University. And it has 11 faculties, 5 graduate schools, and 3 vocational schools. And currently I'm director of one of these vocational colleges at the moment. And well, actually Gazi University, one of the 10 top universities in Turkey. And also though it has been awarded as a research university in Turkey as well. And it has more than 50,000 undergraduate students and 15 graduate students available now in the Gazi University. And now you can see some pictures of Gazi University buildings. Well, in my research group, I have members, and all of them my MSc and PhD students. They are working with me. Some of them are actually working as a full-time students, and some of them are working in companies, but actually they are continuing their MSc and PhD students under some research projects, of course. And we have now, actually, including me, we have 19 and 2 coming students also. We are going to be 22 or 21 in the near future. So it's a large group, and actually, but they are all working very hard and they have very good motivation. Well, actually, what we are doing, basically, we are doing research on metal additive manufacturing, wire arc additive manufacturing, one of these powder bed fusion processes like SLM and EBM, and we also work on design for additive manufacturing and topology optimization. Well, actually, we call it as advanced manufacturing because also we are dealing with some of the some non-conventional processes like EDM and ECM processes, especially applicable for aero engine parts and components, but nowadays we are working ECM and EDM of the additive manufacturing parts as well. And also one of my special interests is repair technologies, which was my PhD topic. So I'm continuing this topic as well, and also we do some kind of post-processing of additively manufactured parts. One of them is laser polishing. So these are our research topic that we are currently working on by giving my students and as well as the research projects. So first of all, I would like to give my first topic that is being done by PhD students Mehmet Molla Mahmutoğlu, and as far as I can see that he is now in one of the participants in this lecture, in this talk. Well, actually, in this PhD work, Mehmet is working on some volumetric laser model for SLM process. And we know that one of the biggest issues in SLM process is predicting the melt pool geometry in 2 dimension and 3 dimension, and also by considering the heat source energy model, the laser actually. So, and what we did basically, we considered the shrinkage effect, because when the laser hit the powder surface, and literally we observed that there's going to be a shrinkage, and the powder is going to be a bit scaled down. And so therefore, when we considering the melt pool in 2 dimension and 3 dimension, we have to consider this shrinkage effect. And we develop a volumetric model by considering the heat transfers during the melting of the powders. And also the Mehmet also writes a computer code to actually mimic these mechanisms, and so we can we are able to predict the temperature distribution and the dimensions of the melt pool, as you can see in this picture. And so we also validate with the literature, and now we are doing some kind of experiments in order to validate at the moment, but mainly we achieve almost very high percentage, but we still, this is still under actually research, so we very in the near future we are going to validate our model, and hopefully we actually develop very a small software in order to predict the melt pool, and in order to actually design the parameters for SLM process, laser powder bed fusion process. My another study very close to, very near to actually the previous one is being done by Ayşe Kübra, and she's also working on melt pool, but in this case she's focusing on how we predict the phase transformation during the SLM process, and it's based on the how much heat we apply to the powder and what is going to be the heating and cooling thermal cycles and interlayer time, and what could be the martensite decomposition. So again, we are working on developing a model by using some kind of softwares like console, and then actually we predict the thermal gradients and the cooling rates, and then actually what is going to be done after the process, and especially for titanium 6-4, can we reach the martensite transformation, and what could be the effect of layer thickness on this martensite decomposition by considering the heating and the cooling rates. Well, this is under, again, the research, so she's continuing his PhD, and these are the first, basically the first results of her study. And well, we do some research mainly actually on the post-processing of the additively manufactured parts, because we know that the parts have very poor surfaces. The surface roughness is very bad, so we need to remove them, or we need to actually improve them. So basically, we have a setup, or we have an experimental actually machine, which is a laser beam machine, and we do some kind of laser polishing processes. Basically, the laser polishing is a known process, but we apply for the especially EBM surfaces made of titanium 6-4 and Inconel. And this is a research project which is supervised by me and Yusuf Kaynak in Marmara University. And well, actually we did many different experiments, and in order to find out which are the best and optimum parameters for laser polishing of the surfaces, how we could improve the surface, and what are the effects of the laser on the surface, because we observed some of the cracks and oxidation, some elevated edges, and etc. So we tried to actually improve the laser polishing process in order to be applicable for improving the surfaces of additively manufactured parts, mainly the EBM parts, basically. Well, actually, yeah, we work on the powder bed fusion processes, but we also work on the wire additive manufacturing methods, which is based on, which is one of the DAD process, directed energy deposition process. And in this process, we use a wire, and we use an arc, and we deposit mainly high volume and solids and dense parts. Well, in this process, in this work, which is being done by Ahmed Suat, and he's my PhD study, and he's going to be actually completed his PhD very soon. And he did many experiments in order to find out the to develop a process for for high strength alloy steels, and we use a robotic wound system, which was located in the Integral company, and we did many different experiments and find out the effect of the process parameters, and we try to also calculate the interlayer times and optimize them, and we measure some of the mechanical properties, and we did many different tests in order to apply, in order to find out what could be the best, actually the best properties for this kind of material. And also we do some analysis, macroscopic analysis as well, in order to actually investigate the effect of process on the grain structures and to optimize them as well. And also we have some kind of heat model to determine the interlayer time to be able to actually produce dense parts with no defect or with the good quality mechanical properties. One of my MSc students, Mustafa Kash, he worked on actually porous structures which are used in medical industries, and he actually he did his MSc on radially graded porous structures, and he did some designs, and he developed a biomimetic approach and to radially graded porous structures, and we actually developed some designs and produced some mechanical parts by using powder bed fusion process in the machine developed by the Armaxon, and also we did some compression tests, and we tested the the strength, compressive strength, and the ductility and the fracture mechanics of this design. And while it was a very successful process and successful designs we achieved, and so we're still developing and we're still working on these structures in order to have good compressive stress capabilities. Well, my next actually work on designing or the redesigning of some kind of parts, and one of them is some kind of satellite parts, and this work was being done by Mehmet Emin Badr, and in his MSc he did very good work, and he did some topological optimization for a satellite brackets, and then he did many different analysis like vibration analysis, some structural analysis as well, and we did some tests as well. I have another presentation, and I would like to actually show you some video as well, so I'm going to pass these slides, because I will explain it more in the next. And my MSc student Umut, actually he also worked on the design for additive manufacturing again for EBM process. And well, his MSc is going to be completed very soon, but he worked on the revolute joint design, and our aim was to design some kind of consolidated parts and revolute joints to be able to actually work them and to manufacture them as it is, okay? But in order to do that, actually, we have to have some kind of design rules. So as you can see some pictures in here, so they design and manufacture it as it is. So they are all working, they are all revolving. But of course, we have to be sure about what could be the tolerance ranges, tolerance rates, and what could be the minimum angles, and what could be the minimum dimensions. So therefore, in this MSc thesis, we actually have some, we develop some design rules for EVM process for revolute joints. Mr. Chairman, I saw a person who actually raised his hands, so probably we are going to answer them questions at the end or now.
Or would you like to answer end of the presentation?
Well, it's up to you. I mean, it doesn't matter.
As you wish. We can allow to talk him.
Yeah, sure.
Okay. Yes, Mr. Mesut.
Thank you for your presentation, Professor Oğuzhan Yılmaz. I actually would like to know how you deal with residual stress, especially in wire arc additive manufacturing process.
Yeah, well, actually, the residual stress is very critical in wire arc additive manufacturing, and we're still working on. And one of my PhD students has this topic. I didn't actually. Yes, we did some measurements, but I didn't put them in here. Sorry about it. Well, firstly, we saw that there is going to be a very huge amount of distortion. Okay, and residual stresses, yeah, it is available, and yes, we did some measurements, but actually, at the end of the day, you cannot escape from residual stresses. So we are planning to firstly do some post-processing, like you putting them in a furnace, so heat treatment process at the moment. There are some way for like vibrational, the relieving some residual stresses, but at the moment we are not focusing on the residual stresses. We are focusing on mainly the producing such kind of parts without any faults and with satisfying some mechanical properties.
I actually would like to know, because I had contribution with Cranfield University. You most probably know them.
Yeah.
I'm actually wondering how, because in titanium 6.4 especially, we have really anisotropic mechanical behavior.
Yeah.
I don't know, did you like optimize the process to
Well, we didn't work on the titanium 6.4 so far.
Isn't it for titanium 6.4? Because
no, this is high strength low alloy steels.
Okay, that's
for titanium 6.4, as you know that you need to have a closed chamber and full of argon, and it needs some kind of equipments and some kind of special chamber for it. But as you said, actually, residual stress is very critical, very critical. Yeah. And we have another research project, but I didn't put it in here, but we probably actually dealing with these residual stresses for titanium 6.4, but it is very at the beginning, actually. So maybe we will discuss it later with you actually.
Yeah, sure.
Personally.
Yeah.
Okay. Thank you very much for your contribution.
Thank you.
Well, yeah, these are some of my, not all of them, some of my actually PhD and MSc studies, mostly completed one. And also we are actually, we have some progress, some of the ongoing and completed industrial and academic research projects, and I would like to mention about them. And first, one of them is actually, this is a SLM machine, powder bed fusion process machine, which was designed and developed by Ermaksan It's a company in Turkey located in Bursa. And well, actually, this is a TÜBİTAK project, and I was one of the members of this research team. And well, actually, it is an honor for me to be a part of this team and to design and to develop this machine. So this machine is now a working machine, and they are selling this also machine as well. So therefore, one of actually the projects that's very honored to be part of the as a member. And also, well, actually, about 10 years ago, actually, we started the VAM process by constructing such a primitive machine. This is a thick type of, the torch, as you can see, and we externally fed the wire, and we work on some stainless steel parts. And I work with my my PhD student. He graduated, Adnan. He's in Iraq now. And well, actually, we did many different works and published papers for this work, actually. And we were able to, develop such kind of very basic shapes and also machine them, and we test them, and we did many analysis, like microstructure analysis, and we were very successful about it, actually. So I am very proud of, showing you such a machine. And also I have a project it's going to be finished very soon, and with FNSS, defense company in Turkey. And Ahmet Suat also is also researching this project. And the FNSS company actually was aiming to manufacture one of the ring, as you can see in this picture, by using WAM system. And we successfully did, and without any fault and any and with satisfying all the mechanical properties. And as I said, the project is going to be finished very soon, in a couple of months. And one of my project is just started yet with Integro company, which is a robotic company in Turkey, in Ankara. And well, actually, in this project, we are aiming to develop a robotic WAM system, which is having some kind of online and offline control systems, and it's going to be very well, actually, highly technological, actually, manufacturing cell, a WAM system, and all the conceptual design has finished, and also the Enes Gebel is probably one of the participants. He's also working as a researcher in this project, one of my PhD students. And well, in this manufacturing cell, the WAM cell, actually we are aiming to, as a whole system, starting from the CAD model to the near net shape manufacturing. And it has also some kind of arc sense, tight sense, and arc voltage, heat input, melt pool monitoring system as well. Well, as I said, it's going to be a highly technological machines. Is going to be developed and manufactured maybe in 2 years, but we are still, so we are at the beginning of the project. And also, well, actually, we have a prospective research project with Fraunhofer in Germany, and for repair. Well, repair is a kind of a related technology for additive manufacturing, because when I was working in Nottingham University, my PhD study is related with repair. So we were using DAD systems with powder and wire, and we were calling the repair technology as additive and subtractive manufacturing systems. So I'm still continuing on this research, and I have contact with Fraunhofer, and we did actually give a couple of research projects to European funds. We refused, unfortunately, but we keep trying. And also the Turkish aerospace industry, which is TEİ in Eskişehir, also they are also one of the actual collaborators in these projects. And so we keep trying to get the funds for this research project. And also we have another project with Fraunhofer and TAI. It's a prospective research project. Actually, it is under evaluating in TÜBİTAK. This is about how we remove the supports from these metallic components. Well, normally, these are dirty secrets of the additive manufacturing, because removing of such a support is very labor work, and it sometimes needs very special tools, and also it is very, very difficult to remove them. And we propose a research project to develop a machining strategy in order to remove those supports from the metallic components. Okay, and this is the outline of this project, and we submitted this project to TÜBİTAK, but we haven't got the result yet, and hopefully it's going to be funded, and then hopefully we work with TI and the Fraunhofer Institute. And I have another research project with Turkish aerospace industry. And in these research projects, we try to redesign and manufacture of critical components for helicopters. And firstly, of course, in these projects, we have manufacture and the design stages. And in the design stage, we are going to use some kind of topological approach in order to redesign the current parts. And also, we are going to manufacture them and test them. But firstly, and this is the first year of this project, and firstly, in order to qualify the machine and qualify the process and qualify the materials, we produced some of, as you can see, some of the coupons, and then we tested them, and we have very good results, which is satisfying to all the all the mechanical properties that we need. And as I said, this is the research project, the 2 years research project. We are in the first year. So this is the redesign of manufacturing satellite components. So I would like to show you some of the videos, not explaining them, but we started from the very beginning of the brackets. This is the first design of the bracket, and this is the last design of the brackets. And while this is the whole all the stages are being done, and finished project, completed project, very successfully completed. We design it, we actually test it, analyze, manufacture it, and also the tests are very, very tough. And vibration tests, some kind of other mechanical tests we did and successfully actually completed. So we are waiting for the Turkish Space Technology Research Institute to put them in the satellite and send it actually, or launch it to the space. So if you allow me, actually, I would like to show my videos and how we design and how we test it. And this is actually the vibration test. We apply 2 types of tests: vibration test, sign test, and the random vibration test. Well, this was very tough test, and so we apply from different orientation. We get results, and as you can see in the video now, actually, so our parts passed this test successfully. Well, as I said, actually, we are waiting for the TÜBİTAK Uzay and launching these brackets to space, and it's going to be honored. It's going to be a very privileged situation for us. And well, actually, we have another research project with Atlas KBS, which is a medium-sized company, design company. Well, they develop a machine for 3D printing of composite dies, especially for aerospace companies as well. Actually, they have a machine, as you can see. This is the conceptual design, but they developed it and they designed it. And as you can see from this picture, this is an extrusion-based process. And it is mixed with some kind of particles and make them composites, okay? They developed the, and I give them actually advisory, academic advisory, and we developed, as you can see, extrusion system with the heating coils, okay? And also there is a kind of a very small roller system in here, very attached to the heads. So when the material is extruded on the nozzle, and there was a roller system that actually rolled the layer. So therefore, we can have good dimensional tolerances and good dimensional stabilities, as you can see in here. And of course, this is a near net shape, so it should be machined and obtain the some of the the models and the parts. Well, this is it, and I would like to thank to all my collaborators, and actually these are my collaborators, and thank you very much all of them for supporting me and my group. And so thank you very much them all. So most of them are space, aerospace and defense companies, but there are some the software companies as well. They are giving us some kind of softwares to be used in my research group. So we have actually the websites amtrg.com, and you may actually visit our website and follow our research and actually publications and what we are doing basically.